In this video, I will do a lot of examples on how to rationalize the denominator and simplify radical expressions. If you are not confident with the basics on how to rationalize the denominator, feel free to watch my previous video on how to rationalize the denominator. Also, feel free to pause the video after each example and try it yourself. Let's start with 2 over the square root of 3. Multiplying the top and the bottom of the fraction by the square root of 3 gives us 2 times the square root of 3 on the top and 3 at the bottom of the fraction. We don't need to write the multiplication sign between the two fractions. You can also extend the line when you feel comfortable with that. The product of the square root of 3 times the square root of 3 we can write as the square root of 3 times 3, which is the square root of 9, which is 3. Or you can write it as the square root of 3 times 3, which is the square root of 3 squared, which is also 3. Or you can write it as the square root of 3 and raise that to the power of 2, which is also 3. Or the easiest way, just write the 3. Let's look at this example. 3 over the square root of 5. Multiplying the top and the bottom of the fraction by the square root of 5 gives us 3 times the square root of 5 in the numerator and 5 in the denominator. What about 5 over the square root of 7? Again, multiplying the top and the bottom of the fraction by the square root of 7 gives us 5 times the square root of 7 and 7. And we are done with this problem. Let's look at this example. 2 over the square root of 10. Multiplying by the square root of 10 on the top and at the bottom gives us 2 times the square root of 10 on the top and 10 at the bottom. After cancelling out the 2 and 10, we get the square root of 10 over 5. Three over the square root of x. Again, multiplying the top and the bottom of the fraction by the square root of x gives us 3 times the square root of x over x. 10 over the square root of 5x. Multiplying the top and the bottom of the fraction by the square root of 5x gives us 10 times the square root of 5x over 5x. After cancelling out the 10 and 5, we get 2 times the square root of 5x over x. Let's look at some examples where we have a square root on the top and at the bottom of the fraction. The square root of 36x squared over the square root of 2x. After applying the division law for roots, we get the square root of 36x squared over 2x. And after cancelling out the 36 and 2 and x squared and x, we get the square root of 18x over 1, which is the square root of 18x. We can write the square root of 18x as the square root of 9 times 2x. Applying the multiplication law for roots, we get the square root of 9 times the square root of 2x, which is 3 times 2x. The square root of 48, a to the 4, over the square root of 12a. Again, after applying the division law for roots, we get the square root of 48, a to the 4, over 12a. And after cancelling out 48 and 12, and the 4 and a, and then applying the division law for roots in reverse, we get the square root of 4a to the 3 over the square root of 1. The square root of 1 is 1, so we get the square root of 4a to the 3, which we can write with the multiplication law for roots as the square root of 4 times the square root of a squared times the square root of a, which is then 2a times the square root of a. The square root of 55 a b to the 5 over the square root of 5ab. Again, after applying the division law for roots, we get the square root of 55a b to the 5 over 5ab. And after cancelling out the 55 and 5, and a, and 5 and b, and then applying the division law for roots in reverse, we get the square root of 11b to the 4 over the square root of 1. The square root of 1 is 1, so we get the square root of 11b to the 4, which we can write with the multiplication law for roots as the square root of 11 times the square root of b squared times the square root of b squared, which is then b squared times the square root of 11. The square root of 11 over 3. After applying the division law for roots, we get the square root of 11 over the square root of 3. Multiplying with the square root of 3 over the square root of 3 gives us, by applying the multiplication law for roots, on the top the square root of 11 times 3 and on the bottom 3. So we get the square root of 33 over 3. Be careful here, don't cancel out the 33 and the 3 because the square root has priority over division. 1 over 2 times the square root of x. 1 multiplied by the square root of x is the square root of x. And 2 times the square root of x times the square root of x is 2x. The square root of x over 3. After applying the division law for roots, we get the square root of x over the square root of 3. Multiplying with the square root of 3 over the square root of 3 gives us the square root of 3x over 3. The square root of 2 over 3. After applying the division law for roots, we get the square root of 2 over the square root of 3. Multiplying by the square root of 3 over the square root of 3, and by applying the multiplication law for roots, we get the square root of 2 times 3 over 3. The square root of 2 times 3 is the square root of 6, and we get the square root of 6 over 3. The square root of a over 2c. After applying the division law for roots, we get the square root of a over the square root of 2c. Multiplying by the square root of 2c over the square root of 2c and by applying the multiplication law for roots, we get the square root of 2ac over 2c. 7 over the third root of 2. The third root disappears when we raise the 2 under the root to the power of 3. When there is no power, like here in our example, the power is equivalent to the power of 1. So to get the 3 out of the exponent 1, we have to multiply the third root of 2 by the third root of 2 to the 2. Because 1 plus 2 equals 3. So multiplying the third root of 2 by the third root of 2 squared gives us the third root of 2 to the 1 plus 2. On the top we get 7 times the third root of 4. So we get 7 times the third root of 4 over the third root of 2 to the 3, which is then 7 times the third root of 4 over 2. the third root of 4 over 5. After applying the division law for roots, we get the third root of 4 over the third root of 5. Multiplying the third root of 5 with the third root of 5 to the 2 makes a 3 out of the 1. After applying the multiplication law for roots on the top, we get the third root of 4 times 5 squared, which is 4 times 25. On the top, we get the third root of 100, and at the bottom, we keep the 5. The third root of 1 over x squared. Again, after applying the division law for roots, we get the third root of 1 over the third root of x squared. Multiplying by the third root of x on the top, and at the bottom, we get the third root of 1 times x and the third root of x squared times x to the 1. One times x is x, and x squared times x is x to the 3. After cancelling out the 3, we get the third root of x over x. 4 over the fifth root of 6. Again, how can we get a 5 out of the 1? Multiplying by the fifth root of 6 to the 4 gives us the 5 in the exponent. Which we then can cancel out. Six to the 4 is 1296. And after cancelling out the 4 and 6, we get 2 times the fifth root of 1296 over 3. Two over the third root of 2. After multiplying with the third root of 2 to the 2, we get 2 times the third root of 4 over the third root of 2 to the 1 times 2 to the 2. After cancelling out the 2, we get the third root of 4. Two over the third root of 4x to the 5. How can we make both exponents of the 4 and of the x a 3? We can do that by just multiplying with the third root of 4 to the 2 times x to the negative 2. After applying the multiplication law for roots, we get the third root of 4 to the 1 times 4 to the 2 times x to the 5 times x to the negative 2. And on the top we get 2 times the third root of 16x to the negative 2. Four to the 1 times 4 to the 2 is 4 to the 3. And x to the 5 times x to the negative 2 is x to the 3. We get the third root of 4x in parentheses to the 3. And finally, after cancelling out the 3, we get 4x in the denominator. The numerator stays the same. And after cancelling out the 2 and 4, we get finally the third root of 16x to the negative 2 over 2x. The square root of 6x to the 3 times y over the square root of 10x to the 4 times y. Because of the division law for roots, we get the square root of 6x to the 3 times y over 10x to the 4 times y. And after cancelling out the 6 and 10, x to the 3 and 4, and y, and then applying the division law for roots in reverse, we get the square root of 3 over the square root of 5x. We can remove the square root of 5x by multiplying it by the square root of 5x. Because of the multiplication law for roots, we get the square root of 3 times 5x, which is the square root of 15x, and at the bottom 5x of the fraction. After cancelling out the 24 and the 40, the a to the 4 and 5, the b and b, we get the square root of 3 over the square root of 5a. Multiplying by the square root of 5a, we get on the top, by applying the multiplication rule for roots, the square root of 3 times 5a, and at the bottom 5a. The square root of 3 times 5a is the square root of 15a, and we are done with this problem. Two over the third root of 4x squared. Multiplying the bottom with the third root of 4 to the 2 times x to the 1, and applying the multiplication law for roots gives us the third root of 4 to the 3 times the third root of x to the 3. On the top, we get 2 times the third root of 16x. The third root of 4 to the 3 is 4, and the third root of x to the 3 is x. And after cancelling out the 2 and 4, we get the third root of 16x over 2x. We can write the third root of 16x as the third root of 8 times the third root of 2x. The third root of 8 is 2. And after cancelling out the 2, we get the third root of 2x over x. 2 over the third root of 4. Multiplying by the third root of 4 to the 2, gives us the third root of 4 to the 3, and 2 times the third root of 16. After cancelling out the 3, we get 4 at the bottom, and after cancelling out the 2 and 4, we get the third root of 16 over 2. We can write the third root of 16 as the third root of 8 times the third root of 2. The third root of 8 is 2, so we can cancel out the third root of 8 and the 2, and we get the third root of 2. 2 over the third root of 4 to the 5. After multiplying the third root of 4 to the negative 2, we get the third root of 4 to the 5 times 4 to the negative 2. When multiplying exponents with the same base, we can add the exponents. So we get the third root of 4 to the 5 plus negative 2. Which is 4 to the 3. And after cancelling out the 3, we get 4 at the bottom of our fraction. Cancelling out the 2 and 4, leads us to the third root of 4 to the negative 2 over 2. If the problem says to write your answer without roots, you can write the third root of 4 to the negative 2 as 4 raised to the negative 2 over 3. Over the third root of 3x. After multiplying by the third root of 3x in parentheses squared, we get 3x in the denominator and 2 times the third root of 3x in parentheses squared in the numerator. 15 over the fourth root of 5x. After multiplying by the fourth root of 5x in parentheses and then raised to 3, we get 5x in the denominator and 15 times the fourth root of 5x in parentheses and then raised to the 3 in the numerator. Cancelling out the 15 and 5 leads us to 3 times the fourth root of 5x in parentheses and then raised to the 3 over x. Applying the power of product rule, we get 5 to the 3 times x to the 3. 5 to the 3 is 125. So we get 3 times the fourth root of 125x to the 3 over x. 1 over the square root of x to the 3 times y to the 4. Multiplying with the square root of x to the negative 1 times y to the negative 2. And applying the multiplication law for roots gives us the square root of x squared times the square root of y squared. Which is then x times y. X to the negative 1 we can write with the rule for negative exponent as 1 over x, and y to the negative 2 we can write as 1 over y squared. With the multiplication rule for roots, we can write the numerator as the square root of 1 over x times the square root of 1 over y squared. And with the division rule for roots, we get the square root of 1 over the square root of x times the square root of 1 over the square root of y squared. The square root of 1 is 1. And the square root of y squared is y. Dividing fractions we do by keeping the first fraction and multiplying by the inverse of the second fraction. One times 1 is 1. And in the denominator we get x times y squared times the square root of x. We can remove the square root of x by multiplying with the square root of x. One times the square root of x is the square root of x. The square root of x times the square root of x is x. So we get x squared times y squared. Three over the third root of 4. Multiplying by the third root of 4 squared gives us a 4 in the denominator and 3 times the third root of 16 in the numerator. The third root of 16 we can write as the third root of 8 times the third root of 2, which is then 2 times the square root of 2. And after cancelling the 2 and 4, we get 3 times the square root of 2 over 2. 1 over the 10th root of x to the 8 times y to the 7 times z to the 6. After multiplying with the 10th root of x to the 2 times y to the 3 and z to the 4, we get in the numerator the 10th root of x squared times y to the 3 times z to the 4 and in the denominator the 10th root of x to the 10 times y to the 10 times z to the 10. So finally we get the 10th root of x squared times y to the 3 times z to the 4 over x, y, z. Let's look at some examples where we have to multiply with the conjugate of the denominator to make the denominator rational. 3 over 4 minus the square root of 5. The conjugate of 4 minus the square root of 5 is 4 plus the square root of 5. Don't forget the parentheses here. 3 times 4 is 12. And 3 times the square root of 5 is 3 times the square root of 5. The third binomial is very helpful here, so I highly recommend memorizing it. A plus b times a minus b is equal to a squared minus b squared. So we get 16 minus 5, which is 11. And we are done with this problem. 2 over 3 minus the square root of 5. The conjugate of 3 minus the square root of 5 is 3 plus the square root of 5. Two times 3 is 6. And 2 times the square root of 5 is 2 times the square root of 5. 3 squared is 9. Minus the square root of 5 squared is 5. So we get 6 plus 2 times the square root of 5 over 4. We see in this example that sometimes it's better not to multiply the numerator. So we keep the 2 times 3 plus the square root of 5, and after cancelling out the 2 and 4, we get 3 plus the square root of 5 over 2. Negative 2 over 3 minus the square root of 5. Again, multiplying with the conjugate of 3 minus the square root of 5. Leads us to 9 minus 5, which is 4. And after cancelling out the 2 and 4, we get negative 3 minus the square root of 5 over 2. Five over the square root of y minus 3. Again, multiplying with the conjugate of the square root of y minus 3, which is the square root of y plus 3. Leads us to y minus 9 in the denominator, and 5 times the square root of y plus 15 in the numerator. One over the square root of 3 plus the square root of 5. The conjugate of the square root of 3 plus the square root of 5 is the square root of 3 minus the square root of 5. And by applying the third binomial, we get 3 minus 5, which is negative 2. And we keep the numerator. Negative 3 over 4 minus the square root of 5. The conjugate of 4 minus the square root of 5 is 4 plus the square root of 5. So we get in the denominator 16 minus 5, which is 11. And in the numerator we get negative 3 times 4, which is negative 12. Minus 3 times the square root of 5. Two plus the square root of 3 over 4 plus the square root of 5. The conjugate of 4 plus the square root of 5 is 4 minus the square root of 5. Four squared is 16, and the square root of 5 squared is 5. 2 times 4 is 8. 2 times negative the square root of 5 is minus 2 times the square root of 5. Then we have the square root of 3 times 4. And minus the square root of 3 times the square root of 5. 16 minus 5 is 11. And in the numerator we get 8 minus 2 times the square root of 5 plus 4 times the square root of 3 minus the square root of 15. Negative 5 over the square root of x minus 5. The conjugate of the square root of x minus 5 is the square root of x plus 5. The square root of x squared is x, and 5 squared is 25. On the top we get negative 5 times the square root of x minus 25. The square root of x over the square root of x plus 1. The conjugate of the square root of x plus 1 is the square root of x minus 1. The square root of x squared is x, and 1 squared is 1. The square root of x times the square root of x is x, and the square root of x times -1 is minus the square root of x. Two plus 3 times the square root of 5 over 7 minus 2 times the square root of 5. The conjugate of 7 minus 2 times the square root of 5 is 7 plus 2 times the square root of 5. Two times 7 is 14. 2 times 2 times the square root of 5 is 4 times the square root of 5. 3 times the square root of 5 times 7 is 21 times the square root of 5. And 3 times the square root of 5 times 2 times the square root of 5 is 6 times 5. And in the denominator we get 7 squared, which is 49. And 2 times the square root of 5 in parentheses and then squared is 4 times 5. 14 plus 30 is 44. And 4 times the square root of 5 plus 21 times the square root of 5 is 25 times the square root of 5. 49 minus 20 is 29. And we keep the numerator. Two times the square root of 3 minus 5 over 3 times the square root of 5 plus 3. The conjugate of 3 times the square root of 5 plus 3 is 3 times the square root of 5 minus 3. Two times the square root of 3 times 3 times the square root of 5 is 6 times the square root of 15. 2 times the square root of 3 times -3 is minus 6 times the square root of 3. -5 times 3 times the square root of 5 is minus 15 times the square root of 5. And -5 times -3 is plus 15. In the denominator, we get 3 times the square root of 5 squared minus 3 squared. We can write the numerator as 3 times 2 times the square root of 15 minus 2 times the square root of 3 minus 5 times the square root of 5 plus 5. 3 times the square root of 5 squared is 9 times 5, which is 45. And 3 squared is 9. (45) minus 9 is 36. After cancelling the 3 and 36, we get 2 times the square root of 15 minus 2 times the square root of 3 minus 5 times the square root of 5 plus 5 over 12. Three times the square root of a minus the square root of 5 over 4 times the square root of a plus 2 times the square root of b. The conjugate of 4 times the square root of a plus 2 times the square root of b is 4 times the square root of a minus 2 times the square root of b. Three times the square root of a times 4 times the square root of a is 12a. 3 times the square root of a times negative 2 times the square root of b is minus 6 times the square root of ab. The negative square root of 5 times 4 times the square root of a is minus 4 times the square root of 5a, and the negative square root of 5 times the negative 2 times the square root of b is plus 2 times the square root of 5b. Four times the square root of a squared is 16a, and 2 times the square root of b squared is 4 times b. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.